name's Elijah Meeks. I'm a senior data visualization engineer at Netflix, where I build custom data visualization for internal teams. So we build dashboards and custom applications for checking to see how Netflix algorithms perform, how the non-member funnel performs, so whether or not people are becoming members at Netflix, how people are navigating through the site, that kind of thing. I'm also the author of D3JS in Action, which is a book published by Manning, and now in a second edition, updated for D3 v4. If you're interested in understanding how to use D3 and React together, there's a chapter in my new book, the new edition of my book, Chapter 9, that goes into detail on teaching you how to build a dashboard in React with D3. I also published a shortened version of that on Medium. If you guys just want to start to get into the kind of work that I'm going to describe in this talk. And the code's up on GitHub, so you can go and just copy it, and you don't even have to pay for the book. It's all free. So that's all available. I was hunting for a high-resolution image of the cover of my book. And I thought it was really cool that the highest resolution, like the best image, was of the Korean edition of my book, which is really cool because, that's right, there is no Korean edition to my book. So, at Netflix, they discuss piracy as a competition, right? It's a problem of not competing well. So I just assumed that I'm not competing well enough in Korea to have stopped somebody from. I would like to humor myself by saying they have translated the entire book into Korean, but I haven't read it, so I can't tell you for sure. So I titled this talk D3 plus React, How but also why. Originally, the talk was about sort of the pain of putting this together. But really what I wanted to talk about was I was going to tell you how to bring React and D3 together. But I think what I want you guys to focus on as we're talking about this, and as I sort of go into the details on the approaches that I take, is to think about, well, why are you doing that? And what are the affordances that each of these libraries provide you to allow you to achieve what your goal is, which is, with data visualization, effective communication of information. So to get into that, when we talk about making, first of all, just a show of hands, how many of you are familiar with D3? How many of you have programmed enough with D3 that you feel good about it? And how many, same thing about React? Like how many of you are like React? And how many of you have brought D3 and React together? Wow, all right. That's great, because it's kind of a Venn diagram, right? And we've got like Venn diagrams coming up. It's really interesting when you go and Google virtual DOM React, you get these cool little tree diagrams. And when you go Google enter exit update in D3, you get a lot of Venn diagrams. I think that's really interesting because I'm a data visualization person, and so I wonder, well, what does that say about people? That the way that they're visualizing what is fundamentally the same activity with these very different forms. And this, I think, fundamentally explains why it can be kind of daunting to take D3 and React and make them play together. Because D3 and React both, at least out of the box, tell you that they want to work with the DOM, right? D3 wants to bind data to a selection of DOM elements and create new DOM elements when there's more data than DOM elements, and remove DOM elements when there's less data than DOM elements. React does the same thing with its virtual DOM diffing. And yet you've got this sort of hierarchical chart here when people are thinking about how React deals with virtual DOM. And you have this very primitive sort of Venn diagram when people deal with how D3 wants to manipulate the DOM. So fundamentally, when you think about there being these two different ways of dealing with the DOM, you see the sort of first response that people typically have to how to make D3 and React deal together. And that's this sort of handoff method. And I use this, depending on what the situation is, I'll use this method. When I built this Archer visualization, which you can go to archervisualization.herokuapp.com, I used primarily this method. This is a visualization of all the episodes of Archer. Archer is a cartoon about horrible people. And along with a data scientist in New England, Mara Averick, we did this project where we visualized all of the episodes of Archer. And we built it in React, and we used D3 for all the data visualization. And the mechanism that we used to integrate D3 in React was this handoff. And so what do I mean by handoff? Well, it's pretty straightforward. For those of you familiar with React components have a render method. That method generates the DOM components the DOM elements that component has created. And those elements can have a ref property. And that ref property gives you a reference to the actual DOM node that's been created. So an actual node in the DOM, as opposed to sort of a virtual node that React deals with. And you can take that node, and the typical pattern that you've seen is you assign it to this dot node, but you can take it however you want, however you can store it. And you pass it using the rest of React's lifecycle events to some kind of D3 function. So React creates the node, and somewhere near the bottom of the list, you create typically an SVG element. You take that SVG element, and in these other lifecycle events, like component will mount or component did update, you use that reference, and you pass that over, and React doesn't know what's going on, and you do D3 to it. And that's a fundamentally straightforward way of dealing with things. So in the case of the splat, which was my way of referring to this radial interrupted bump chart, bump area chart with skull and crossbones. There was a splat function, and I passed to the splat function the reference to the node, a few other properties that I got from the size of the node at the time. And then I did what you think of as traditional D3 stuff over on the right. So the SVG node variable up here is just that node. I select it with d3.select. I'm using d3v4, and I'm importing these as modules, so it's just select and select all. But it's all of the stuff that if you're familiar with D3, this should be familiar to you. I'm binding data to it. I'm creating new elements. I'm transitioning those elements when I assign new positions or new sizes to them or shapes or colors. And over in the React component, the component itself is pretty primitive. It has a render method. That render method initializes that DOM element. And then I refer to this function in the component lifecycle events. This is a really useful method, especially if there's two things that are happening. One is that nobody else is really dealing with your code. So like if you don't have to work with other people, especially in industry, who have to understand what you're doing, then you can write all the D3 style code you want. I found at Netflix that once you start writing too much code in the way that the D3 community typically writes code, trying to get other people to understand that, other people who perhaps didn't grow up like learning how to code in the way that D3 describes how you should code, it can be challenging for how you might work together on a team. The other aspect of it is that there's a lot of animation here. There's a lot of non-reusable elements here. I'm not going to use an interrupted radial bump area chart in too many other places. There's some interesting filter effects and all sorts of things that are going on here that I didn't really have to worry about anybody understanding but me, and that I wasn't going to go deploy again across several applications. Now, if you're not in that kind of situation, if you're building something that's a little more staid, that doesn't involve tigers eating people, like what we've got here, which is a piece out of the A/B testing platform that we use at Netflix. So how we compare how a control cell versus several different versions of Netflix when they're showing you, and they're making typically Adam Sandler related things much, much larger, so you'll try to click on more Adam Sandler. We visualize the various effects of those changes in a table, but along with the numerical values and the statistical significance of the changes, we also show some of these ranges, and we show simple spark lines and things like that. And in this case, use a second method. And that second method I like to refer to as sort of the visualization kernel. And this is based on a talk that Mike Bostock gave a while back where he talked about D3 as an information visualization kernel. So in this case, it is also pretty straightforward. D3 has a huge surface area. There's a lot of different functionality in D3. And the selections and the transitions, you don't have to use those at all. So in the case of the example I've got up on the screen right now, I'm using arc, which is out of the D3 shape part of the D3 library. Arc takes an object that defines a start angle and an end angle. It's what's used when you create a pie chart. Each individual piece of a pie chart is created with an arc. I can take that, and I could use d3.select, .bind data, and blah, blah, blah. Or I could simply say my data.map and return some JSX elements and use that arc generator to just determine what the D attribute of those JSX paths would be. And so in this case, you don't use any of the enter, exit, update. You don't use any of the sort of Venn diagram part of D3. And you just use the parts of D3 that are optimized for doing what? Determining the position of visual elements, their size, their shape, their color, based on the data that they represent. And that means you just drop what can be, a significant portion of the D3 library, which is perfectly fine. The challenge with this is that in comparison to the earlier example, hardly any of the applications at Netflix where I'm using just this sort of pure mode have any animation whatsoever. They'll have some mouse over effects, right? React deals with mouse events just fine. But there's not going to be any of the sort of complicated tweening or morphing of shapes that you see with D3. I'm not going to use this method if I want to deploy like a network diagram and where the positions are updating constantly. And so these two methods are actually pretty straightforward. It's, like 2 years ago that Shirley Wu talked about how to make D3 and React work together. She fundamentally talked about the same kind of things. And so I know that we're still doing that. But what I want to focus on moving forward is why do we want to make React and D3 work together? And I know what the practical answer to that question is, which is that I work at a place that uses React, and I need to use data visualization. So why am I making them work together? Well, those are the two technologies that I have, and they have to work together. But what are the benefits that we can see actually out of integrating React and D3? What kind of different approaches to data visualization can we take based on what each of them does well? Well, let's think about this. What are React's strengths? React actually does DOM diffing really well, especially in comparison to D3. The reason why you have that very sort of shallow diagram, that Venn diagram, is because D3 does DOM diffing, but it does DOM diffing with the help of a very particular library, which is you. Right? D3 does DOM diffing as long as you tell it, what am I binding to everything all the way down that hierarchy within the DOM. That's why when we look at that React diagram, when people think about DOM diffing in React, they think about a tree. When they think about DOM diffing in D3, they think about a single unidimensional event. React also has custom components, and it has custom components that are also other SVG components. So, finally, React comes with JSX. Now, JSX isn't a part of React, but I love JSX, and I think that I hated JSX for like the first week, and I think that for a lot of people with React, maybe that's the response. What are the weaknesses? Well, React doesn't have a good sort of tweening, morphing layer to it. Like in comparison to the worry-free DOM diffing that React does, anytime you ever look at any sort of animation libraries with React, there's a lot of hand tooling that you have to do to make elements animate in a way that's completely brainless and worry-free in D3. And when you know exactly what you're updating in your data visualization, when you know exactly what DOM elements are being updated, the performance is much better in D3 because you can control all of it by hand. So when I built a network visualization of feedback networks based on 360 feedback at Netflix. I actually just used that D3 handoff method because there was a lot of network diagrams that were constantly animating that position and animation. I didn't want to worry about sending that as some kind of dynamic state to React and watch React sort of struggle with doing that DOM diffing. Any kind of animations that you can do in React with CSS are great, but once you start to do anything that has to do with sort of transitioning shapes, and it depends on what kind of positions, but some certain kinds of positions can be problematic. Which, let me tell you, if any of you want to work on that, I would love, please, some kind of nice React library that was as brainless and simple for me to create dynamic animations like this as I can in D3. Because so far, what I've looked at in React is a lot of XML nightmare and exact settings, and it makes me think that it just isn't the kind of thing that I would expect, given the way that React deals with the virtual DOM. So what are D3's strengths? Well, it's really great at information visualization, right? Like, it's a data visualization library. You have layouts and you have generators, and they're efficient and they are effective, and it also does animated transitions well. You take a path shape and you take another path shape, and it will most of the time do a pretty good job of animating from one shape to another, from one position to another. And when you have to do something more complicated, it's actually pretty painless to get in there and write your own custom tweens. It also has a bunch of nice helper components for data visualization, like brushes and axes and zooms. The problem is that those really nice components all follow this very dirty call structure that's difficult to integrate into React because you have to, again, pass it that node reference. And if you start mutating DOM elements in React and you're not sure that it's at the very bottom and that React will never touch them again, then you know that you'll run into these errors. There's a lot of D3 that I don't use anymore. There's the formatting parts of D3. I use numeral and I use moment. And I use React for managing the DOM. And I think that for a lot of folks, when they come and look at D3 and they see this big mono library, they sort of assume that they have to use all of it to get access to all of it. But really, there's a lot of drawing parts to D3, these layouts and these generators that you can use, and you never have to use D3's way of updating the DOM or dealing with any of those issues. So when we talk about like the handoff or the information visualization kernel, well, I kind of built a data visualization framework where sometimes I handed off the node, and sometimes I used D3 as a pure information visualization kernel. And why would I do that, right? Like, if there's one good method or one good method, then why don't you just use one or the other? Well, it turns out that D3 does some things really well, like those animated transitions, and I don't want to deal with learning somebody's sort of way of thinking about animations in React. But at the same time, I want to be able to create a bar in a bar chart, and I want that bar sometimes to be a single element, and I want that bar sometimes to be a dozen elements. So like if I want to render a sketchy bar chart or a painty stacked bar chart, under the hood, that's not a single rect element. That's sometimes a rect element, and sometimes it's multiple path elements. And that might seem like a rather sort of facile example. How many people are actually doing sketchy rendering? They call it non-photorealistic rendering, which I think is really funny, because like, what's a photorealistic data visualization? But there are real reasons for using non-deterministic marks. So here's an example. So I work 5 feet away from Susie Liu, who wrote this great annotation library. And if you look at this diagram, you've got a non-deterministic mark in this line for this line chart. We create a threshold on the line chart of above $100 for Apple's stock price. And whenever the stock price goes above that threshold, it needs to render different paths for the parts that are above it than below it. So you can imagine, as you change this threshold, there could be a single path element being rendered for this line, or there could be dozens of path elements being rendered for this line. And this is something that D3 doesn't do very well out of the box. It's not sort of built into the philosophy of the library. And that comes into play later on as we were building some connected scatter plots. These are the performance of a couple of different shows. that I won't get into in too much detail. So on the top are connected scatter plots. At the bottom are difference lines. The dashed line is the performance of some particular metric across Netflix as a whole. And then when the show on the left is doing better than Netflix, it's in green. When it's doing worse, it's in red. Actually, so each of these columns is a show. We're comparing two of them. So a difference line like this, a difference chart, is another one of these non-deterministic marks, where if it's entirely over, then you could have a single path. But as it crosses back and forth, you could have multiple paths. But then, by the same vein, I want these marks to transition back and forth between each other when that makes sense. Not just because it's sort of like attractive to have a bump chart transition into a stacked area chart transition into a line chart, but actually because it's important if I want my stakeholders to use a stacked area chart or use a bump area chart, maybe not a radial interrupted bump area chart, but a regular bump area chart, it's helpful to them if that starts out as a chart that they better understand, like a line chart. So when I was building this framework, I made sure that all of these pieces that exist within the same frame, whether it's an XY frame or sort of a more categorical frame like you would see for bar charts, could transition into every expression that frame allows for. So in this case, what you're seeing is a bump chart, which bases position on rank, a line chart, a stacked area chart, and then a bump area chart where the actual position of the areas changes if the rank changes. And this library is called Semiotic, and I was going to release it today, but then I got a little bit sick, and also I kind of got caught up in making goofy things with contours. So it'll be released at some point soon. It's not like a configuration-based charting library like what you see with, recharts and stuff like that. It deals with that mark interface, and it deals with that frame interface, and it tries to explore these possibilities of what we can represent. And it also lets you do sketchy rendering all the time if you want to. That's about what I've got. Be happy to take questions.